This outcome is to identify the domain of a rational function. Given the symbolic form, here we're just looking at the symbolic form of a rational function. Remember, rational is fractional. Function that looks like a fraction. The student will identify the domain of the function and write it in interval notation correctly. And so I have two examples right here. This rational function f of x equals x plus 1 over 2x minus 3. And so when we try to identify the domain, we're going to look at the restrictions. And the restrictions for a rational function is not having a 0. We cannot have 0 in the denominator. So that's what's going to help us know what the domain is. And the same for this one. So we're going to take the denominator and set it to equal 0 to find out what makes it 0, so we can exclude that from the domain because we can't have 0. So let's look at those two examples here. So for this function to be defined, the denominator cannot be 0. So the 2x minus 3 cannot equal 0. However, we're going to take the 2x minus 3 and set it to equal 0 so we can find what the x value that we need to avoid that makes it 0, so we can exclude that from the domain. So I'm going to take the denominator, set it to equal 0, solve this equation by adding 3 to both sides. So we got 2x equals 3, divide both sides by 2, x equals 3/2. So 3/2 makes it 0. That means we can't really have 3/2 in the domain. So that means the domain is all real numbers except 3/2. And to write this domain in interval notation, I really like to look at the number line. So if that's the number line, there's 0. There's 1, 2, 3, and so on. 3/2 is 1.5 right here. So there is 3/2. And so we can't have 3/2. So I'm going to put an open circle there. But we can have everything else on the number line. So how do we exclude 3/2 by using interval notation? Remember, interval notation, you have to write it left to right. And so we're going to go from the left, and that's from negative infinity, go right to 3/2. But 3/2 is not going to be included, so I'm going to put parentheses here. If you put brackets, that means you include it, so you have to be careful. And then we're going to take the union with the second interval, which starts as 3/2, but 3/2 is not included. So again, it's an open interval going all the way to infinity. So this is the interval notation of the domain. So that's the domain of this rational function. Let's look at this second example here. OK, so we know that the denominator cannot be 0. So x squared minus 5x plus 4 cannot equal 0. However, just like we said earlier, we're going to set it to equal 0 to find what makes it 0 so we can exclude it. And so when we set it to equal 0, we notice that this is a quadratic equation that we're solving. And so we're going to try to solve it by factoring. X squared factors to x times x. 4, I'm going to try 4 and 1. The last term is positive, so we're going to go with both negative. Inside is negative 1x, outside is negative 4x, so that gives you negative 5x. So make sure you factor correctly. And now you're going to take each factor and set it to equal 0. That's using the 0 factor property. X minus 1 is equal to 0, or x minus 4 is equal to 0. And when you solve this one by adding 1 to both sides, x equals 1. And if you add 4 to both sides here, you get x equals 4. But notice that 1 and 4 makes the bottom 0, so we can't have 1, we can't have 4. And so that means the domain is all real numbers except all real numbers except 1 or 4. So how do we write it in interval notation? Again, I'd like to look at the number line. So this is the number line, and I'm going to go to 1. I can't have 1, so I'm going to circle it, and I'm going to go to 2, 3, 4, go to 4. I can't have 4, so I'm going to circle that, 4. And then, but I can have everything in between. So I can have this interval, the one in between, and that one going all the way to infinity. And how I write this in interval notation? I'm going to start from left to right, negative infinity. I'm going to stop at 1 and exclude the 1 by putting an open interval. Union, the second interval that goes from 1 to 4. It's open at both ends because it's excluding 1 and 4. Union 4 to infinity. Thank you. See you next time.